So now we're gonna see the EN family that is given in our chapter. So first of all, the first member is methane. Methane, as we all know, a single carbon compound is carbon needed, and then we satisfy the valency by hydrogen 1, 2, 3, 4 total 1, 2, 3, 4, 5, 6. A single line represents two electrons. One is here and one is here. As two electrons share, then form a single bond. So here is the structure of methane, and if we form a loose dot structure. So here is the news dot structure of the methane. Here we can say the single orbital contains electron of carbon and electron of hydrogen, and carbon has 1, 2, 3, 4, 5, 6, 7, 8. It's 4 electron and 4 from the rest 4 hydrogen. Now we take for ethane. Ethane, it's another. Here the en represent 2. We can list it like meth 1, eth 2, prop 3, but 4, pent 5, hex 6. So here is ethene. So basically one carbon compound form, and here one H H H H H H H X, and there is X dot H, X dot H. So basically here we get and now for the rest. So basically this is the structure of loose dot structure of ethane. Now for third, that is propane. Propane is third. So here we form 3 carbon. Now we can say a single bond is there, so rest how many bonds we have to form? 4 bonds. So one bond is already formed, so another hydrogen, another hydrogen, another hydrogen. Here 2 bonds already, so 2 hydrogen, 3 hydrogen. X dot H, X dot H, X dot H, X carbon, X carbon, X dot H, X dot H, X dot H, X dot H, X dot H. So here is a whole orbital of a single carbon atom. Here is the dot itself, and then we form another, that is this is the second carbon orbital, and then the third. So this is the loose dot structure of propane. Now for butane. Butane is again 4 carbon, 1, 2, 3, and 4. Now one hydrogen, 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 one hydrogen. Like 2 bonds are already there, only need 2 hydrogen. This is the structure of butane. Let's make it like that: carbon dot hydrogen, carbon dot hydrogen, carbon dot hydrogen, carbon X, another carbon, carbon X, carbon another carbon, 1, 2, 3, and 4th. So here carbon dot H, the hydrogen orbital, carbon dot H, hydrogen orbital, carbon dot H, hydrogen orbital, and carbon dot H, and here carbon dot H. So the sum from the carbon. Now carbon dot H, another, and last carbon dot H hydrogen orbital. Now if we make this carbon orbital, then again 4 carbon orbital, again 4 carbon orbital, again form a carbon orbital. So basically this is the structure of butane: 1 carbon, 2 carbon, 3 carbon, 4 carbon. So this is butane. Now fifth, pentene. Carbon, 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 hydrogen, 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 hydrogen. So 1 2 3 4 5. The 5 pentene is the structure here. So if we want to make it, then here form carbon X dot H 1 carbon, 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 1 carbon, 2 carbon, 3 carbon, 3 and 5 carbons are there. Now hydrogen orbital, so basically this is structure 1 2 3 and 4 5. 1 2 3 4 5. This is a Lewis dog structure of a pentene. Now we're going to make the hexane next page. Last compound that we have is hexane. So here the 6 carbon are there and we satisfy it with the valency of the hydrogen. So basically we know that only if 2 bonds are already formed, then we have to form so just 2 hydrogen atom. For last only 1 bond is formed, so rest 3 will be formed same way here. So now 1 2 3 4 5 6. Now if we form the Lewis dog structure, 1 carbon, 1 carbon, 1 carbon, 3 4 5 and 6. So basically the hydrogen here also. So now we form a order orbital of carbon. So here we can say first, 2, 3, 4th, 5th and 6 carbons are there, and 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14 are there. So basically it's C6H14, and as we know the formula of the NEN is NH2N plus 1. So if the 6 is 6, N is 6. Now if N is 6, then H 2 multiplied to 12 plus 1 or 12 plus 2 is there, so 12 plus 2 is there, so C6H14 will be the formula. Same we can verify by here. So if we N equals to 5, so C5 H10 plus 12, so N4, that is C4 H10, and here we H12 because 5 2 multiplied by 5 10 and plus 2 is 12. So now N3 C3 H6 plus 8, N2 C2 H6, that is H6 because N is 2 and then 2 and 4 plus 2 is 6. N1 is a C1H4. So basically this is the first one, that is the methane. It can justify as, the formula can justify as methane. We have seen the 6 and here hydrogen, hydrogen, hydrogen and hydrogen. So basically it forms a methane structure that is there. So C4 is for N1, C2H6 for N2, and C3 is C3H8 is for 3, and 4 is C4H10, and 5 is C5H12, and 6 4 is C6H14. So we have seen this is the electron dot structure, the formula, the structure, the basically you can see the skeleton, and the skeleton basically this structure we can say. And at the same time, if this is the structure and there are 2, 3 and 4, so this can form like 2 and here this structure can form like alongside it. At the same time, this is a 4 can be formed like a square. So basically this is called the circular, is a cylindric, is a we can say a circular structure, basically a cyclic structure. Cyclic structure is, this is a cyclic structure, this is a branch structure, and this is normal skeletal system. And here we have also seen a compound that is a benzene. Benzene is seen like its alternative bonds. So 3, 4, 6. So we here have to add alternative bonds, and last is here. So basically this is the structure of benzene, as already 3 bonds form one hydrogen, already 3 bonds form one hydrogen, and already 3 bonds of one hydrogen, and already 3 bonds of one hydrogen, last one hydrogen, and last here also one hydrogen. So basically this is the structure of benzene. This is a aromatic compound. The cyclic structure basically also known as the aromatic compounds. Obviously there is some condition to be cyclic structure of aromatic compound, which we will study in the further classes. This can be skeleton also called as linear skeleton structure. Basically this is unbranched, or we can say unbranched. So it was seen as linear skeleton structure, unbranched structure, branch structure, cyclic structure, and aromatic structure, and the condition we study in further class.